Okay, and welcome back to second lecture for the week about loops. All right, in theory, this should be new. However, we're going to start by minimizing and going back because I said I was going to cover the last couple of slides. All right, because there's a couple of things in here that are really, really important. So even if I just talk about the slides and copy and paste and run the code and explain what's going on, I think that's better than me completely ignoring them. Okay, well this one's fine. Maybe I'll do the next one because it's a little more complicated. All right, so summation pattern. We are going to end up having to add things up a whole pile of times. Okay, so it's not going to be just sort of once where you add something up and it's already happened. No, you're probably going to find that you have to add things up an awful lot of times. Like, for example, I mean, we had the exercise, I guess, last class. In fact, I'll do that one. We were asking for a whole bunch of test scores. So you know what? Let's do that again. It'll take a couple of seconds to write it up. Let's go with the approach of this style. Okay, so remember this one, set up the infinite loop. And what I will do is we'll have something called a test number, because I will need that one in a minute. All right, and we're going to start off with test number 1. Okay, test number 1. We'll adjust that in a second. Remember, I've said this before. Programming, by the way, is iterative. It's not like, oh, I know what I'm going to do at the beginning and you need to do it. No. But if you do remember, we had something like this where we said, okay, let's go and ask for a score. So here we go, enter test score. All right, and we had an option in here that said, okay, if the score was exactly equal to -1, basically get out, okay? Otherwise, we're going to do some other stuff, okay? So I'll just replace it with the word stuff for right now. I have no idea what that means, and eventually we're going to say done. All right. Here we go. So here's the idea. The program is going to ask the user to enter a bunch of test scores to put in a -1, and then we're going to do something. What we're going to do is we're going to calculate the average test score. Okay, but you know what I've said before, let's just run this to make sure that it works. So I put a bunch of values in. When I put in a -1, it stops. That's a really good place to get started because, yeah, it doesn't solve the problem. It doesn't calculate the average, however you do that. We'll talk about that in a second. But at least the main loop works. And if you're not sure what to do, this is a really good place to start. In fact, if somebody said, hey, you know what, I want to enter and I want to have the test number here, well, this is a really good spot to put this. Okay, here we go. You got to spell it right. And of course, it's got to be as one of these F strings. Okay, so enter test score 1, enter test, okay, yeah, we need to do something. And at what point would it be good to increment that? Okay, maybe at the bottom of the loop. I'm not sure. You could try this in a different spot, but here you go. So now we've got the ability, okay, the big test scores, that's fine. That's good enough. Hey, at least we got ourselves a loop. All right, now on to the real problem. So what is the problem that we're trying to solve here today? Okay, so right here, I'll just mark it down, so just in case, that way, because I know if I say it, maybe it isn't quite as clear, but if I write it, it's usually better. Ask the user to enter a bunch is not a very technical term, but that's fine. Enter a bunch of test scores and compute the average of the scores. Okay, there you go. That's pretty straightforward. All right, so of course my problem decomposition is I started off by saying we'll just ask the user to enter a bunch of test scores. Oh, and of course stop asking when the user enters -1. So that was my decomposition. I said, okay, let's get the loop going first until you put it in a -1. At that point, stop. Now, to calculate the average of a bunch of test scores, okay, well, the magic formula is you need the total of all the test scores ever entered, and you need to divide that by the number of tests that were actually taken. All right, so here we go. What we're going to do is we need to come up with the total test scores. All right, well, to come up with the total test scores, it's a very, very typical pattern. It's always the same thing. It doesn't matter if it's an input statement like this. It's not going to matter when we cover this in lists and dictionaries. It will be exactly the same thing. What you do is you start with something called the accumulator. Okay, you don't type the word accumulator, by the way, I have. And what you do is you initialize the accumulator to be 0. You think about this. If you take an old calculator, there we go, so old style calculator, very, very simple. Here you go, there's a calculator. If I wanted to calculate a bunch of test scores, what do? Well, I press enter, I enter the numbers, I put a bunch of pluses. Do you notice what number's there right now before I start? Yeah, because obviously the first thing you're going to start with is nothing. And to that, maybe you're going to add a 90. And to that, maybe you're going to add an 80. Okay, these types of things. All right, put that away. So it's called the accumulator. Now, I wouldn't call it the accumulator as a variable name. What I might do is I might use the word called total scores. Okay, that's one possibility. Or maybe the score sum. Okay, that's fine. Scores? Not a good idea, because scores would probably mean the actual scores themselves. It's just me talking out loud about what makes a good variable and what doesn't. Okay, S, a little too generic, right? Okay, the total scores entered by the user. Yeah, it's a little too much because you have to keep typing it over and over again, and it just makes your program really hard to read. So, and you remember what I said, 1 or 2 words is usually pretty good. Oh, I know, sum. No. Okay, good. We could use it, but we shouldn't. That's because there is something built into Python called sum. We will cover it once we have lists, and then you'll say, wow, yeah, why didn't we do this before? Well, it's because you need to have a list. Okay, and we don't have lists yet, but eventually I will show you what this is. I think what I'll use is score total. I don't even like total score. I think score total sounds better, but the exact name is not so important, but you have some ideas now about what would make a good name and what might not. All right, so all that we're going to do is we're going to simply say whatever the user types in, we're basically going to add. So we started at 0, and if somebody puts in 10, well, then 10 gets 10 values larger. You see, back over here in the world of the calculator, okay, we started with a 0, and if I go and I add 80 and press enter, what's the total right now? 80. And if I put another 10, 80 was here. If I then add another 10, what does it become? 90. So you don't go back to 0 each time, you just keep building on top of it, okay? All right, so the accumulator, you simply add what you're looking for. Now, obviously we need to do this each time that we ask the user. I've got many places where I can put it. I could put it right here. Well, no, I can't put it right there because I haven't asked for the score yet. Okay, I could put it maybe right here where I could add it. So let's put the cursor here. There's an issue with this one. In fact, I'm going to put it here, and if you're looking at it saying, hey, that's a mistake, yeah, good. Okay, so this is one of my purposeful mistakes. All right, so here's what I'm going to do. Score total is equal to, and I'll spell it out this way this time, score total plus score. So what I'm doing is I'm taking the 0, and then I'm going to add something to it. Add the 20, add the 30, add the 40, and so on. All right, and then, of course, at the end, I'm going to have to print this out. Give me 1 second. My database system is always complaining. Here we go. That's gone away. All right. What I need to do is I need to know what is the score total at the end, because that's going to become very, very important, because obviously if that number is wrong, it means our average is going to be wrong. And although I don't mind putting up my hand after I get it working, running, and asking the instructor, hey, what did I do wrong? It's easier if you come up with a way to solve it yourself, and that means you have to know what values you've got inside which variables. Okay, so here's what I'm going to do. I'm going to put this in, I'm just going to say total, and we'll say score total. There we go. I just want to know the score total. Okay, nothing else. That's not the average, but it's the score total. Problem decomposition. You need the score total to be able to calculate the average. All right, now, somebody may give you a whole pile of examples with a whole bunch of test scores in it. I recommend always ignoring those and starting with something very, very simple. Okay, so here we go. 10. I don't care if it's pass or fail. All right, and 20. Okay, and 30. And I'm going to put a -1 here, but I'm going to have to ask you beforehand, what should the total score be with those numbers that I just put in? 60. Should be 60, because I grab a calculator and try it. Don't worry about any other crazy examples that the instructor gives. Just make up your own. In fact, if you wanted to, 1, 1, 1, and -1, that would even be easier. Okay, so this better be 60. But it comes up as 59. Oh. Okay. We know, so you see, if I did an average calculation, I wouldn't know where the problem was. All right, but now we know that there's an issue, so let's find out why. Well, think about this. Remember, just before I press -1 and press enter, remember the program was, once again, stuck pending. On line 10, the person typed in -1, and what did I do? I added -1 to the score total. And as a result, it brought it down by 1. That's not the right place to put it. You can only do this after you have made a decision about whether or not it's a good score. In fact, if you wanted to add that check, if it's bigger than 100, less than 0, throw the whole thing out, you would put this sum afterwards. All right, so same thing again, 1, 1, 1, and -1. What should it give me? 3. Okay, good. Okay, and you could try a couple of others. All right, excellent. So that's the total. Second thing I need to do is I need to figure out the average. Well, sorry, the next thing is the average. To calculate the average, it's the sum, which, good, now it works. And of course, we would need to divide by the number of tests. Okay, excellent. So looks like there's something in here called test number. Will that do what I want it to do? Well, I guess, you could sit there and reason about whether or not it will, but an easy check is printed. You see, you guys are very, very lucky for one thing. Let's call it just a num test. And let me explain while I'm waiting for this, or for my fingers to type. Okay, I just want to print this value to see what's inside. How much does it cost you to print a variable during a test? Okay, what do I mean by it doesn't cost money, but I'm talking time. How much time does it take for you to put in a print and run your program again? No, it has time. How much? 2 seconds, okay. Maybe somebody types really slow, 30 seconds. Okay, it's really slow. All right, it doesn't take long. Yeah, absolutely. Yeah, I can describe some of the development processes, stuff that I've worked on, and I don't even mean just back when I was in university. A platform that I did work on before coming here, it was also an old platform. It used to take 30 minutes from the time that you said, okay, I want to build this, and it would take like a couple of minutes to build. Then you'd have to put it onto a platform for actually testing. It used to take a half an hour. So a half an hour just to find out what the value is. Yeah, you learn how to debug code in different ways. This is great now because basically it costs nothing, as you said, to run it. Okay, let's find out what's inside the thing called test num, because maybe test number is exactly what I want. All right. Okay, what's the total? Yeah, the total, score total. 150, okay, good. And how many values were there? 3, okay. So, and by the way, the average of 50, 50, and 50 should be 50 because it's 150 divided by 3. All right, so, we can't use it. It doesn't quite work. It's one number too big. Okay, well, remember what I said the other day. Quite often what people will do is they will start something at 0, and they will simply add 1 when they print it, but this way you see when the loop is done, it'll have exactly the value that we're looking for. All right, so here we go. It's the 60, 40 to make it 100, and a 10, and another one that'll be 110 and -1. There we go, 120 and 4. We've gotten very, very close. So the only final thing left to do is, of course, to calculate the average, which is going to be the score total divided by the test number. Oh, test number. Maybe I would flip this around at this point and call it number of tests, num tests. Okay, yeah. Variable name refactoring. All right, I'm not going to do too much more, but we will print the average. Okay, so AVG is equal to average. Okay, so here we go. The first one, easy, 80, 80, 80, -1. What should the average be?
8.
Excellent. All right, now we'll run another one without even running a calculator. Okay, so here we go. 80, 80, 100, and -1. Okay, I know that you're not going to know exactly the number. I don't care about that, but I'm going to ask, should the average now be higher or lower than what it was a minute ago? It should be slightly higher, not a lot higher, but it should be a little bit higher. And okay, 86 seems feasible if we wanted to, okay, grab a calculator, actually do the calculations. But yeah, the total should work out. The number of tests is 3. Yeah, we're pretty good. So the pattern behind this, back over to the slides for a second. I can remember to not take too long, otherwise I will run out of time for the next slides. And the next slides are pretty quick. All right. Yeah, you can see here I've got an accumulator. They call it total. Yeah, that's very, very popular. Just call it total. It's really a bill total. And you can see inside, where's my cursor? Here we go. Inside the loop, just after I asked for the input, I simply said that, well, total is equal to total plus bill amount. How come I don't have that break thing? Because this is a counted loop and it's going exactly 5 times. Okay, that's the difference. But the rest of the pattern for summing is same thing. Initialize something to be 0, take the value, add the value, the number that you just got, and keep adding it to make it bigger and bigger and bigger. Okay, let's solve a different problem. Again, not this one because that's a little bit more tricky. Okay, let's get rid of the average stuff for a second. Okay, so to get rid of the average stuff, I don't need the score total. Okay, I'm just kind of undoing some things. I don't need the score total. Maybe I don't even need the number of tests, so we'll get rid of all that. But I will say done. Oh, and notice the thing that I didn't do. I didn't bother with what the output looks like because that is almost no work. Once you have the values, it's easy to deal with the print statement. And by the way, if you say, okay, well, because I can't calculate the total, but I'll do a print statement, maybe you'll give me some marks for it. It doesn't work that way. There's really not a lot of marks for like making output statements look correct. Even if you just kind of like tit dot 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 like sometimes I do, you should be getting most of your marks. Actually, you should get all of them. All right, so here we go. Just let me undo the average stuff. I'm going to leave the test number in place because maybe we need it, maybe we don't. And let's see, ask the user to enter a bunch of test scores. Oh. There we go. Stop asking when the user enters -1. Okay, so that's exactly what I've got already. So if I was starting from scratch, I would probably have the full statement, and this is the first thing that I would do. All right, and what we need to do is print the highest test score recorded. Okay? All right, so go and print the highest test score that you ever found. Okay, very, very typical pattern once again. Quite often you're looking for things that are either the highest or the lowest, or eventually what's going to happen is we will end up learning how to sort things. It's one of our objectives towards the end, but for right now, finding the highest and lowest, it is actually kind of important. All right, once again, there's a very common pattern that you use. Okay, here's the pattern. What you do is you basically record every number that comes in and you ask, is this bigger than any other number that I've ever seen before? And if it is, that becomes the biggest number. Okay? It's a very, very common pattern. The pattern will be listed in here. I think I'm showing something a little bit more complicated. I won't do this one here because I'm more interested in just finding the biggest. All right, it's always a very, very common pattern. What you do is you have some kind of a variable that records the maximum. Oh, and by the way, you can't use the word max because guess what? It's also built in. Once again, once we see list, and we'll have it. But what I'm going to have is I'm going to have something called the highest score. All right, now, we leave that as a question mark for right now. Okay, I don't know what to put here. Just we'll fill it out in a second. All right. When a score comes in, it could be -1. We just learned a few seconds ago, should I put anything right here? And the answer is no way. Because that's going to be my termination value, my sentinel value, basically get past that first because you know that a -1 is going to mess things up big time. All right, here's what I'm going to ask. You see, I'm going to ask whether or not score was bigger than the highest score that we've ever seen. If it is, then I'm going to take the highest score and I'm going to replace it with whatever the user just typed. That's it. Okay, that's all that we need to do. Now, there's going to be a few odd cases in here we're going to have to deal with, and we'll talk about how you'd handle them. But in any case, so there we go. Basically, if the next score coming in is higher than the biggest thing we've ever seen, then we're finished. Or we simply replace it and we keep going. Sorry, I'm looking at a -1 saying we're finished. All right, the question then becomes is, what do you set this to? Okay, that's a very typical thing. Why did you pick 0? Because every score that the user's going to put in is probably going to be bigger than, with the exception of the -1, but that's a special case. Yeah, that's exactly it. Normally what you do is you make the highest score a really, really small number. You could even make it -1. We'll try this in a second. And I can explain why maybe you would consider doing this. Okay, just to give you some things to think about, some logic for more difficult problems. So you start off with a 0 because, well, you know somebody's probably gotten a score bigger than 0. And if nobody's gotten a score bigger than 0, then the instructor will be investigated, right? Yeah, okay, good. All right, let's give it a try. Okay, oh, and by the way, I'll keep asking these questions. Remember, these are live variables. I wish you could see what was going inside. Maybe I should add something so it just like hovers and it says, this is the current value. That'd actually be a really cool thing. All right, so what's the value of highest score right now? 0, because what's happened is it got initialized as 0, and I'm on line number 11 for the very first time, and I'm pending for the input. All right, so what I'm going to do is I'm going to type in the number 70. When I press enter, well, that's going to be skipped, and I'm going to ask the question, is score bigger than the highest score? Yes. Of course it is. So what do? Well, the highest score becomes 70. All right, and then you repeat. Okay, if I put a 60, you see, what's going to happen is, obviously, this first if statement's not going to trigger, but I'm going to ask the question, is score bigger than the highest score? No. And no, it isn't, so it's going to be ignored. It still increases the test number, okay, but that's it. And if I put a 90, that's going to replace it. And finally, if I put a -1, it'll stop the loop, and it'll be incredibly boring because it's just going to say, done. Oh, whoops, okay, well, that was really boring. Now we have no idea what it was. Okay, I was probably interested in the highest score. So sorry, now we got to repeat it again. So 60, okay, let's make something kind of big and we'll pick something kind of small. All right, so what happened was the first 70 would have triggered the update, the 90 would have triggered an update, the 56 would have been ignored, and the -1 would have stopped the entire thing. Congratulations, that's the biggest. Okay. Okay, first score is 0. Next score is 0. Next score is 0. Okay, investigation pending. That's the end of the list. And what's the highest score? 0. Ah, excellent. That's really nice. Okay. All right, enter first test score, -1. Okay, but what's the highest score? Yeah, because we initialize them. Now, this could be an issue, okay, because how many scores did I enter? None. Okay, so can you even ask what the highest score is if there's no entries? And the answer is not really. Okay, all right, so sometimes you may bump into these things where it says, okay, well, here's what I'm going to do. If there was no scores entered, we'll print a message saying no tests. Okay, rather than printing the value. So then we look at it and we say, okay, what can we do? Now, we're going to assume that people do not type bad inputs. And you will see a lot of this in this course. There's a lot of times where I say, just assume the input is okay. Because if somebody comes in and starts typing like 8 million and -45, yeah, this whole thing fails. Let's assume they only type between 0 and 100 and the -1 to stop. Okay, we'll assume that everybody's behaving themselves. I know that's not true in all user cases, but let's assume this. Okay, so if I'm looking to determine whether or not there was a problem, what can I do to prevent this highest score from being printed? Okay, so here what we'll do is we'll say highest. Okay, and there's the highest score. Well, you know, it's really just an if statement. Right? Because what I'm interested in is I'm going to print something in one case and I'm going to print no scores entered or whatever other message in the second one. Okay, so what can I put in here inside the question marks to make this decision? I got a couple of options in here, actually. There's actually a really easy one. Oh, if score is equal to 0, now that is incredibly, incredibly dangerous. Okay, but you know what? Because somebody said it, I'm going to do it.
Less than 0 and more than 100.
No. Not quite like this. Okay, 60 minus 1, done. Highest was 60. Yeah, okay, good. Doesn't quite do what we want. Yeah, we're still short. Now, somebody has said, okay, you see, when we reach outside here, score actually does have a value. It was the most recent value entered. And when you reach line number 20, what's the value of score? It's always minus 1, because that's what we use to stop the loop. All right, so no, unfortunately, we really can't look at the value of score, but we got another variable. Yeah, test number. Here we go. You see, if test number is bigger than 0, it means somebody entered at least one test. Okay, so we're using that counter to make a decision on our output. So here we go. Okay, minus 1, so we got the highest was found. And if I just put in a minus 1 directly, it can tell because the test number is equal to 0. Okay, so these are the types of problems you work through. It's an idea, because quite often what I see students do is they will try to put something in and they'll make a decision right away saying, okay, if score is equal to minus 1, then no test entered, but obviously we're using this. Okay, so yeah, you can certainly have logic after the loop. It isn't always just if statements inside the loop. It isn't because sometimes you can have if statements before, sometimes you have them afterwards. It isn't just like, oh, it's always one pattern. And unfortunately, because often we stick with very simple programming patterns here, you don't get a lot of chance to see things like this. So, okay, just consider that a bonus because I happen to think of it right now. It's not even in here. All right, input validation, I don't care because we hardly cover it. Okay, let's toss this away. Okay, somewhere in here I got a set of slides. Here we go, excellent. Okay, so congratulations, we wasted a half an hour. Now I've got a half an hour to try and cover 4 loops. Okay, it's only 13 slides. I mean, how much can I talk about 4 loops? More than you can imagine. But I will behave myself. Actually, I pulled out some other stuff as well this afternoon. I said, hey, good, it's time for me to bring out some Kahoots. These are some fun things that I do. I've got some really tricky and fun problems. I don't know if I'll get to them today. Okay, we'll see how time is going. Maybe we get one of them and then I can pick them up next week. If we don't get them done today, we should be pretty good for next time. All right, so let me toss this aside because you already know I don't read through slides. If you guys want to read through slides, it's fine, but I'm not. Sorry. This one right here is actually worthwhile popping up. Okay, good. So this is an introduction. Okay, so one slide. Okay, Instagram is written using Python. The back end. So what do I mean by the back end? You see, you're used to Instagram being something on a web page or on a mobile phone. Yeah, it's a place where people are putting up videos and so on. I picked this one because I found out that, or I know that it's actually written as Python. And what happens is when you upload a photo, on the back end, the server, there's a whole bunch of Python code making decisions about, okay, do we let the person upload? If somebody clicks on a like, you have to update the database to say it's as many likes and so on. It's all the algorithm implementation. The estimate that I found online is that it's about 100,000 lines of code. It's actually not a very big program. Yeah, 100,000 lines is actually not a really big program. I would say, just as an estimate, Microsoft Word's probably like 500,000 or something. It really is quite big. All right, so it's 100,000 lines of Python. Now, I can never remember what's coming next. Oh, okay, here we go. So 100,000 lines of Python code. Do you suppose they use loops anywhere? Of course they do. Yeah, you can't do anything. And the question they said is, okay, well, how many loops do you think there is? 50,000. That would be really brutal because that would mean that for every line of code, there's a while statement or for loop, and the answer is no. Once again, it's just kind of a rough estimate. Maybe it's about 1,000. Okay, because most of the time when you write up a loop, Yeah, so we're talking maybe 100 lines of code inside every loop. I mean, it's big programs. Usually people would probably write in a different way. So you wouldn't have like hundreds of lines inside a loop. They'd probably be smaller by using functions. All right, so that's fine. So it's 100,000 lines of, 100,000 loops. And you know that we've talked about something called counted loops, and we've talked about sentinel loops. Counted loops are when you know in advance how many times you're going to do something. Sentinel loops are you keep doing something until some condition is satisfied. Okay? All right. So the question then was, okay, if you have 1,000 loops, how many of those are likely to be counted loops versus sentinel loops? Okay, well, it turns out that, again, it's just an estimate. 6,008, I think, I'm guessing they're supposed to be 600 and 800, okay? That would probably be more rather than 8,000 counted loops. And I think maybe the first estimate is supposed to be 10,000. I'll have to fix the slides. All right, but the idea was, yes, it's probably around 60 to 80% are counted loops. They occur more frequently than anything else, okay? And you will discover that today. In fact, I had a student, I don't know who it was, but somebody came down here the other day and said, hey, okay, fine, yeah, we have these wild stuff, but aren't we just going to be using for all the time? And I said, yeah, you'll probably discover that. And that isn't because we favor one type, it's because that's naturally what ends up happening. Okay, now, we're not talking about for loops yet, but we're talking about this thing called counted loops. Most of the loops that you'll ever write in your life will probably be counted loops. In fact, it might even be a higher percentage in here. So because these types of counted loops happen all the time, most programming languages have added some conveniences to make creating counted loops a whole lot easier. Okay, so here we go. We need to go back and we need to have ourselves a problem once again. All right, so here we go. Problem. Okay, ask the user to enter 5 test scores and compute the average. All right, here we go. So we know how to kind of do this already. All right, I think I can probably do this one pretty quick. You know that you're going to need a total score. Okay, it's going to be 0. You know that you're going to have a test number, which is 0. You'd probably, of course, need a while loop that says, well, the test number is less than 5. Yeah, that's it. Don't forget, test number goes up by 1. If you forget that, nothing good happens. What do you get? Infinite loop, it'll happen. All right, here you go. Inside, we'll ask for the score. Okay, int input, and we'll enter, enter test. Okay, test number plus 1 score. Okay, the score, maybe it's a SOAR 2. All right, here we go. And of course, done. And that's good enough for testing, isn't it? Remember what I said? Problem decomposition. Okay, so here we go. 1 test score, 2 test scores, 3 test scores, test score 4, test score 5, and finished. Good. First thing. Oh, average. Forgot to do the average. There's no -1. Okay, so we don't have to check that one. What we will do is we'll say, here we go, total score. Total score goes up by score. That's every time. All right, and here we go. Print. And we'll say total score. I'm not even going to bother calculating the average because are you going to gain much by watching me divide 2 numbers together, or a number divided by 5? Not likely. Okay, but I will have to pick something really simple. 10, 10, 10, 10, and 11. What's the total? 51. Okay, you see, I picked numbers that are really easy to come up with, so I don't have to use a calculator. All right, so 51. So yeah, my total score is working. The average is going to work without an issue. Just take that number, divide it by 5. Okay, because the program asks for 5. Maybe better to make a constant or a variable, but that's fine. Okay, so here we go. Ask the user to enter 5 test scores and compute the average. That, of course, is not a sentinel loop. That is a counted loop because we know in advance how many things there's going to be. All right, and I think I've already pointed out the issue is people are going to forget this. Yeah, it happens. People are going to accidentally use less than or equal to. It happens. People are going to forget to initialize it to 0. Okay, it's going to happen. These are the mistakes that happen all the time. All right, so the makers of Python said, okay, I'm going to follow like every other programming language, and we are going to create a new type of loop that is going to be really useful for counted loops, and that's the whole reason why it exists. All right, the loop is called a for loop. Okay, so here we go. I'll just leave stuff in place. Sorry, I'll copy and paste and move things around in a second. There's a new reserved word, for. Okay. You see, my previous exercise, I never gave this a name. Okay, this I gave you a name. This is called an accumulator. Okay, what's that? It's not an increment. I'm talking about the variable name itself. The increment is right here, yeah. This thing right here I would refer to as the loop variable, okay? The loop counter, okay? For test number, the loop counter, in. Okay. New word for you, range. Ooh, okay, 5, colon. There we go. That's a for loop. You notice a couple of things missing now. And by the way, this will be a perfectly good working program. Let me run it first so you can see it. Okay, so enter test score 1. Okay, again, I'll just pick some simple things. Okay, here we go. Oh, look at that. You see, it's got the test number 1. Well, 1 plus 1 already. Here's another one, another one, another one, and this one right here. This should stop. It should say 51, and it does. Exactly the same program that I just erased. Okay, but differences. You'll notice that my loop counter, I didn't initialize it. Yeah, I didn't initialize it. Notice that I didn't increment it. Notice that I didn't check it against whether or not it was less than 5. Instead, all that I did was I said, okay, I've got this loop counter right here, and I said for this value in range 5, and range 5 is basically what it does, it actually kind of generates a list in the background in case you've seen lists before. And it basically enumerates the values 0, 1, 2, 3, and 4. Okay, and that's it. Just 0, 1, 2, 3, and 4. All right, so what happens is, yeah, it repeats exactly the right number of times with exactly the right values. Okay, just while we're here. Here we go. I'm just going to put test number because we have to make a bunch of changes to these in a few seconds, and we'll call it test number. All right, now I'm starting to go away from my program, so please, this is no longer, there we go. It's no longer calculating the average, it's just printing out test numbers. Okay. The first time that this loop occurs, and it is a loop, by the way, the very first time it happens, the value of test number is 0. Yeah, the next time, then 1, then a 2, then a 3, then a 4, and does it include 5? And the answer is no. Oh, hey, why does it start from 0? Think about the strings. Okay, exactly why we're thinking about this. And there you go. So it's 0 through 4. Oh, so in other words, it's giving you exactly the right positions within a string if you want to pull out the individual letters. Yeah, that's there's a reason why this is happening. Okay, it's to make it convenient. And it's another good reason why your counted loop should start at 0, because this is what's built into Python. And this way, at least your while loops are compatible with the for loops. So that's very useful. Okay, I've already done that one. There's a couple of variations that I can do with this, so I better cover the variations. I guess the first one is, let me put this up to a 20. I think that will probably be good enough. All right, this is not a trick question. How many times will the loop happen? 20 times. What's the biggest number you'll ever see? 19. Yeah, okay, good. Okay, and the smallest number, of course, would be 0. Excellent. There's a variation of this where you can put in 2 numbers. And what this is, I just heard it, was start and stop. Well, sort of. Okay, so the very first time through this loop, the value of test number is going to be 2. Oh, and what's the very last one? 19. Oh, so start at something and go, but don't include the last spot. Sounds to me like list slicing, right? And that's exactly the same idea. Yeah, they didn't say, okay, let's do one thing one way and then we'll mess everybody up by using it a different way in the next part. No, at least they were consistent. All right, so good. So we have this. It's exactly the same concept as what we saw in list slicing. Oh, and if you remember in list slicing, there was yet another value as well that you can stick at the end called the step size. Okay, so here's what happens. The very first number is a start. The next number is a start plus the step size. And you keep going until it becomes too big, at which point you stop. Or just before you become the same value. So in other words, the first value out is going to be 2. What's the next value? 5, okay. And then what's going to be the next value? We'll make the prediction first. 8, okay, you know what? Where's my text editor? I want to see these other things. So we think it's going to be, 2, then 5, then 8. Okay, 11, 14, 17. Oh, okay. So now the question becomes, okay, does it print the 20 or not? And, well, of course, no, because, yeah, it stops just before. We'll try it in a couple of seconds. Okay, we'll try modifying this. So there you go. That's exactly it. Okay. What if it started at 3? Well, obviously there'll be different numbers, but it's going to be the same thing. It's never going to make it to 20. Okay, it'll always be one less. And the same thing is true if I start at 1, it'll stop at the 19 because that's just before. It's exactly the same concept of slicing. Okay, super useful, right? I'll be honest, it's not something I use very often. Okay. I include it because it's just one extra slide I can cover, and it's not really that weird because we've already done slicing, but I'll be honest, it's not something that we will use so often. And the exact same concept is possible over here. Yes, you can certainly have a negative step size. You can start at a number, go down to something. You can see in the second example. Again, it's not something I would use a whole lot, but watch out because sometimes we stick MCQ questions about these behaviors. And it's okay because, you know what, it's really the same thing as list slicing. And sometimes we do need the slicing. Sometimes I might ask it this way. I might ask it as a slicing question. Okay, just be cautious of that one. Okay, let's see. Okay, this one is quite useful. And I don't need those. A second, turn hiding on. Okay, here we go. We've done this one before. Course code. Okay, we're going to ask for a course code. Okay, pretty simple. What type is it going to be? A string, okay. A new use for loops, really cool use for for loops. Okay, I don't like X very often, but sometimes when I'm about to say, okay, here's what we're going to try this, I'll put in X. So we'll replace this in a few seconds. Okay. Okay, there's something new. Okay, wait a minute. We just saw for loops. Yeah, this is a type of a for loop, but I'm not using range. Instead of using range, I'm using a string. Okay, well, let's just start by printing all of these X's, whatever they happen to be. infs1201. That's the course code. Usually one demonstration you say, okay, I get what's happening. A for loop, when you use in a string, what it does is it pulls out exactly one character at a time. And now you can make some decisions about things. Like for example, maybe you want to know whether or not, or you wanted to count how many uppercase letters you've got. Okay, you know what, if I can remember the magic function. Oh, and by the way, I wouldn't use X, I'd probably use CHAR for character. And what I might do is I might say, okay, if CHAR is upper, then print CHAR. Okay, let's call it Python, let's call it intro Python programming. Okay, you see, I get only I, P, and P. So what's happening is I'm going through each of the characters and I'm saying, okay, if the character happens to be an uppercase character, then I print it. Okay, turn it into something for counting and so on. I know that in the infs 1101 course, you often see people checking things about is upper and is lower. Do they cover for loops for this purpose?
Yeah.
Okay, that's interesting. So in that case, I can just trash my slides and I can go forward next. Okay, that's next time. Okay, back over to my slides for a second. I actually have a useful slide to put up. At least I hope it's useful. Okay, this one right here. All right, so there's always a big question. Next is, okay, now I've got two different types of loops. Which one do I pick? All right, here we go. You will never, ever, ever be given a programming problem where you'll be told you must write a program and you must use a for loop or you must use a while loop. I don't do this type of thing. It's an artificial requirement. What I will do is I will simply ask you to solve a problem. If you'd like to solve the problem using a while loop or a for loop, that's entirely up to you. However, my expectation is that you will probably become, I call it lazy. I often call programmers lazy. And this is not to make fun of anybody in this room. Trust me, every programmer, including myself, is lazy. You do the least possible, right? I mean, that is true. You're never going to argue with anybody and say, no, people do it. No, trust me, it's the absolute minimum. All right, if you need a simple counted loop from a start to an end for a certain number of steps, a for loop is definitely going to make your life considerably quicker because it's less typing. You don't have to worry about initializing. You don't have to worry about incrementing, which you'll probably forget. Done. If you ever need to do something until a condition is true, then you have no choice. You have to use a while loop. You see, I can't ask the problem. Well, I'll go back. I'll try this in a second, and we'll actually give it a shot. Let's write back the same program. Okay, make it as simple as possible. Ask the user to enter a bunch of test scores and stop when they enter -1. I'm not even going to worry about anything else. That'll be enough. Obviously, there'll be more to it, like count how many passes, how many fails, what's the average, all this type of stuff. It's not even worry about this. All right, while loop, yeah, you know what it is. While, true, score, int, input, enter, blah, 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 blah. Okay, I would have score is equal to -1, break, print, done. Okay, so score, -1, stop, done, finished. Now you've solved the rest of the problem. Okay, let's turn it into a for loop. Okay, first of all, does a break work with a for? And the answer is yes. Oh, okay, so in that case, it's just a for loop. All right, so here we go. What we're going to do is we just say for. I don't know what to call this yet. For x in range. Oh, you know, I'm supposed to put something in here, but what? How many times do we want the loop to go? Until. Well, no, let's actually make this. So here we go. Until they put -1. So what do I need to put in here? Well, okay, what if I put 4? Yeah, it'll stop at 4. Let me run it for a second. 45 -1. Oh, perfect, it's done. But the limitation is I can only go up to 4, and if somebody wants to put in 10, it's not going to work. All right, so in that case, how about that? I guess you could, but what if there's more than 4,000 scores? It's legit, isn't it? There could be. So somebody says, okay, well, there we go. Because there's probably going to be not that many scores. It still doesn't make it correct. You could use it, that's kind of silly. Okay, so yeah, don't do this. I suppose, okay, you know what, I've never tried this, so this could be tremendous amounts of fun. So I don't know if this is going to work or not. I've actually never tried it. Okay, how about this? Start at 1. Okay. The second number is how far we're going to go, 10. Step size is 0. What do you think? And again, I actually don't know the answer. I've never tried it. You think it'll work, or do you think it'll be some kind of an error?
I think it just take everything.
I don't know, so I guess we find out. Oh, okay, stopped. Okay, so we tried. We tried. Okay. Actually, I wasn't sure whether or not this would actually work. It's good. So actually, it says no. It can't be 0. Okay. How about -1?
Then
Done automatically. Yeah, it's because it's already finished before it started. Okay, so yeah, this is one of these cases. As I say, you could probably use it, but it really doesn't make any sense. It would make more sense to have it as the other format. That's really what you use the while loops for. If you're going over a bunch of characters in string, you use for. We don't have it yet, but when we hit lists, you're going to be using for loops all the time for exactly the same thing, because it's really easy to go through each of the elements inside the list. All right, what have I got? Okay, I'm going to burn through the slides, and that's going to be about it. All right, there's a concept of nested loops. I know there's some exercises in next week's lab about it. All right, so what these are nested loops where you have one loop inside the other. There's going to be a few times when you need it. There's not a lot of exercise. It doesn't happen a whole lot, at least not right now, but eventually we'll get to the point where we really, really need it. And I see there's a really cool exercise or a really cool sample on the next page. I actually can't remember doing it, so maybe it was another instructor who put it in, but I like it. And if it was cool, I can always claim it was mine, but honestly, I don't remember writing it there. Okay, here we go. So I've got 2 loops in here, and yeah, I've gone back to a while loop. It really is kind of like, why would you possibly want to have 2 loops, especially 2 loops inside with each other? Well, what you're doing here is you've got one loop says, okay, we'll keep going while the hour's less than 9, and inside here, what we're doing is we're setting. Ooh, I know this is not mine, because this is definitely not the style of code that I would write. All right, take a look at the program first. So you see it showed for 8 o'clock, then 8:30, then 9 o'clock, then 9:30. And it's actually really cool, because what I could do is I could go up to, say, 12. So it's every 30 minutes. That's kind of cool. So I'm using one to increment one loop, the inside loop to increment the minutes, and the outside loop for incrementing the hours. And what I could do is I could do something like this and pull it down to a 10. And that's also pretty cool, because what is happening is the minutes are incrementing until finally it hits 60, at which point everything flips over and it goes to the next one. Okay, so it's kind of cool. I know that this is not mine, and I will show you the reason why. This is setting the minutes to equal to 0, which, by the way, is absolutely required, and it is absolutely not the way that I would do it. Oh, I'm getting too many lines in here. Let's undo this one. Okay, here we go. Because if I was writing the code, I would have written it like this. Because I like to initialize my counters just before the loop, not at the end. Okay, so yeah, it's somebody else's. But it's a cool idea for as a demonstration. So, of course, what's happening is this loop happens a bunch of times for each hour, but then within each hour, this loop right here happens over and over again. So this is incrementing the minutes, and then once that finishes, then it increments the hour on the outside. As I say, I don't want to spend too much time on nested loops, because although they're kind of important, we really don't do a whole lot of stuff, but yeah. Oh, okay. The break was not a big surprise, right? I mean, well, I told you up front is, guess what? The break does what you want. Wrong format, here we go. And then we say if x is equal to 3, we'll hit break. Okay, and I'm just going to print hello. All right, so here we go, a little bit of a guess the output of this program. Okay, so I'm going to ask. Obviously, the word hello gets printed, maybe. And my question right now is, how many times does the word hello get printed? Okay, so 2.5 times based on the average that I just heard. Some people say 2, some people say 3. Did I hear 4?
Yes.
Okay, how about 8? No, no, I think that would be kind of a surprise. All right, so here we go. Remember, this loop is going to go around. Okay, the values of x. Okay, just generic variables. We don't have a real problem here yet. The very first time through the loop, what's the value of x going to be? 1. 1 is the first one. Okay, second time through, and because it's not equal to 3, the break isn't going to happen, so we're going to print a hello. Okay, this is my hello counter. This is the x. All right, the next time through the loop, x is going to be 2. Okay, is 2 equal to 3? No, so we're not going to break, and we're going to print hello for a second time. All right, next time through, x is going to become 3. And you see on line number 3, it's going to say, is x equal to 3? And it's going to say yes, so we hit a break. What happens when you hit a break? Loop is finished. So how many times do we expect? 2 times. Okay, that's good. Just to make it a little bit more interesting, let's print the numbers as well. Okay, just that way I don't have to count these things up. So it's 1 and 2. Excellent. All right, now let me modify this to be, continue, because what on earth goes on here? Because we remember that a continue would immediately stop everything else, but it doesn't stop the loop, but it goes back up and it does its check. But then the question becomes well, wait a minute, if it doesn't reach the end, does x go up? Or do I go into an infinite loop? Okay, but what about the value of x? Does it increase or not? Okay, so here, we'll run it. All right, so that's exactly what happens. But remember, if it had been a counted loop, you would have found yourself in an infinite loop, because remember where I always put my increment is at the very bottom. Okay, so no, the increments, there is no concept of an increment. So this isn't exactly what's going on here, but what happens is when you go back up and it checks the range again, it does pull the next value. Okay, so it is a little bit fundamentally different than a while loop, because it does actually check these things. All right, so what have we got? Oh, perfect, okay. It's not quite 3, so it's a good spot to almost stop. Not quite. Sorry, officially I do have a half an hour. I'm not going to fill it. But here's what I'm going to do. Remember I said I've got a whole bunch of these fun little Kahoot things. So let me see. This will be like the first one I'll check to find out whether or not anything works. Let me see which one we want to toss in here. Participation is not entirely mandatory. In fact, I know that there's limitations. I think I only get like 40 people, but sometimes I see the number go a little bit higher. All right, the first one says while loops. So just give me a second to get it started. Okay, the super fast internet apparently. Okay, bad news, it started. Well, maybe it's okay. All right, so here we go. And yeah, these are just for fun, by the way. That's all. Continue without an island. I don't know what this means yet. Okay, so this one's all about while loops. Almost all of the problems that I stick in here are always of the form, what's the output of this program? Okay, so I'll give you a couple of minutes to join in. Let's see if we can actually like fill it this time. Usually the first few I do pretty good, and then eventually I get less and less people as we go. Okay, feel free to use whatever names you want. If you pick my name, you have to do well. Because somebody will always do it. Yeah, okay, excellent. In that case, do poorly. Let's see. We have some really annoying music that pops out of this stuff. Sound. Okay, how did we do? Okay, couple more. Okay, you can have another 44. You see, they tell me I'm not supposed to have more than 40 accounts, but anyway. Okay, I think this is good enough. So if you didn't get in this time, that's all right. Next time up. Okay, I think it's only 4 questions this time. It's mostly just checking to find out whether or not these things even work today. All right, they're mostly pretty simple. Mostly. Let's see, I hope I give enough time. Sometimes I give 1 minute. Sometimes if they're difficult, I give 2. If they're incredibly difficult, I give like 5 seconds. That one could be more trouble. Okay, now. Oh, good. I hate the silence. It sounds so weird. Not that I enjoy the music. Okay, running out of time. Oh, hey, good, excellent. Okay, so yes, I heard the pain of like, how am I supposed to calculate A times B times plus? Yeah, it's completely irrelevant because really I was just looking for the count. All right, excellent. So yeah, it's a counted loop. Sorry for 4. All right, because count starts at 0. It's less than 5. So. Yeah, that's all. Okay. Or sorry, well, B is less than 5. All right, so yeah, it's just that one. Okay, excellent. Now we'll look at the user afterwards. Okay, so the user enters 5, then 50, then -1. -1 kind of suggests like it's sent in a loop. Participant limit not reached. I see it now. I think we found a problem. So 4 people seem to have gotten the correct answer of 9, and everybody else gone for, let's see, 10 and 60. Okay, so you just discovered something very, very important about the types of questions that we quite often ask in terms of MCQs here. Okay, and that is quite often what I include in any MCQs, by the way, are what I call plausible distractors. Okay, and what that means is these are things that people will probably misunderstand and go for. In other words, every answer you look at, you go, oh, it could be that, or it could be that, or it could be that, depending on whether or not this is doing the right thing. It's pretty rare that I have like a completely out to lunch answer. All right, remember, okay, we're going to print out the value of A. A starts off at 0. Okay, the first time through the loop, the 5 is less than 10, so it's no problem. A becomes 5. The next time through, they enter another 5, so A becomes 10. The next time through, however, when they enter 50, well, that's skipped. So if you went for 60, you forgot that thing right here. And, of course, the next time when they enter a -1, because it's less than 10, it actually adds the -1 to the value of A, which gives you the 9. Okay, so this is an exercise I did the other day. All right. Oh, same output. Huh, must be the same program. Did I make a mistake? Okay, better? No. What'd you pick 10 for? Alright, I better take a look and find out why. Alright, there's something a little bit weird in this loop, and that is I have an input before the loop, and then an input inside the loop. So in other words, the very first number that went in, which was 5, is completely ignored. Yeah, and so just watch over that one. And of course, did anybody go for 9? I can't remember that one. Oops. Oh, how do you do this now? Okay. A couple of people went for it thinking, yeah, it's the same program. Not quite. Okay. I hope this makes it full screen. Okay, good. All right, one more, then we're done. Not yet. Okay, oh, perfect. You know the answer. How many times does the word hello appear? Okay, I mean, it's not as bad, but an awful lot of people went for the value 1. Okay, better take a look at the media again just to make sure there's nothing weird going on. Sometimes I do make mistakes. All right, so x becomes 3. Okay, inside the while loop, hello gets printed at the top, guaranteed. No matter what happens, 1 is definitely occurring. Next thing I ask, is x, which is currently 3, is it bigger than 10? No, definitely not. So I go and I make x equal to 13. I print the hello on line number 7, and I go back up to the top and I print the hello on line number 3. But now x is equal to 13, so now the next time through on line number 4, x will be bigger than 10, so it will break. Okay? All right, so... okay, so now we can find out who won. All right, so yeah, I've got a whole pile of these. 2, 4, 6, 8, 10, 12. I've got about 12 or 13 of these. We'll bring them out occasionally towards the end of every lesson. And yeah, they're just as difficult. Hey, perfect. Yeah, that's the one that you want at the number 1 spot because that would be sorted, including capital A. So excellent. All right, that's it for the day. Thanks.